Welcome. Did you ask yourself, how does the sun burn when there's no oxygen in space? Bring a burning candle and put it inside a glass cup, and then cover the cup from the top with a book or any cover. Normally, in this situation, the candle flame will gradually decrease until extinguished. This is because ignition requires oxygen, and when we cover the cup, we prevented the oxygen from the candle, and this is very normal. The abnormal is if we compare this mechanism to the sun's ignition mechanism, we will be very confused. The sun is a blazing ball that has been burning for billions of years, and this is despite the fact that there is no oxygen in outer space to help it burn. I wonder what the story is, and is oxygen important for all ignition operations, or are there different ways in which ignition can occur as well? Let's find out together. I am Hussam, and in this episode, I will answer how the sun burns without oxygen in outer space. And before we start, if you are new in the channel, don't forget to subscribe to get our videos right away. Fire is one of the greatest discoveries that literally defines us as human beings and made our life much easier, as it is an essential element in our daily lives and we cannot live without it at all, starting from cooking and heating food to various fields of industry. And fire is a transitional stage, a stage in which a substance changes from the solid state to the liquid state, or from the liquid state to the gaseous state, or even from the gaseous state to the solid state again. Fire is a chemical reaction called a combustion reaction. For this chemical reaction to occur, three basic elements must be present. First, the fuel that will burn, and this could be anything in the world: wood, paper, metal, gaseous, or even liquids, such as gasoline and its derivatives and other liquids. The second element is milieu of ignition. The best milieu for this process is the oxygen we breathe. And the last element is the initiating heat for the ignition process. And this could be an existing flame, or by friction, or any other source of heat. These three elements known as the triangle of fire. If any element is not present, the combustion reaction does not occur. And we can take an example: butane, which is found in our homes. The fuel in this process is the natural gas that comes out of the pipes or tubes. The milieu that helps combustion is the oxygen gas that is present everywhere, and initial heat will be matches or lighter. Well, now let's ask the question: what is the benefit of oxygen in this matter? And why does the ignition process not take place without it? The truth lies in the interaction of oxygen atoms with atoms of burning fuel. Any flammable substance, especially oil, is mostly composed of carbon and hydrogen atoms, and the bonds that band these atoms together are weak and unstable. What happens is that carbon and hydrogen, when exposed to air, decide to leave each other and combines with oxygen atoms in order to be a more stable compound. This process is known as oxidation, and when it happens, it results in a high temperature, and through this high temperature, fire appears. And more oxygen in air, the higher the strength of the flame. We finished the basics. Let's talk about the sun. If we ask anyone to describe the sun, he will probably say that it is a burning ball of fire. Ignition depends on burning the gases inside it to produce light and heat. Don't think of the sun as a candle or burning wood, think of it as a giant hydrogen bomb. The sun and the stars, to produce this light and this heat, they need to fuse billions of atoms, therefore they do not need oxygen, which does not exist in the space. As for the nuclear fusion that occurs inside the sun as follows: the sun is generally composed of gases. About 75% is hydrogen gas and 25% is helium gas, in addition to a very small percentage of other gases and minerals, not exceed 0.1%. The sun has a huge number of hydrogen atoms inside it. Each atom contains a proton that has a positive charge and a negatively charged electron, and if any two hydrogen atoms getting close to each other, they don't merge because of the outer electrons of the two atoms, and the protons inside repel each other. But since the interior of the sun is very hot and at very high pressure, because of this heat, hydrogen atoms gain high kinetic energy. It allows the different hydrogen atoms to come very close to each other. This allows the protons inside the nuclei to fuse, and nuclear fusion takes place. In most cases, four hydrogen atoms fuse to form one helium atom. On the other hand, a very small part of the electron mass is dissipated, result of this interaction, and the mass that was lost turns into a very high energy. You can imagine that the sun in 1 second radiates energy with that huge number. This huge amount of energy comes out every second and has no equal on Earth. If you want to imagine the magnitude of this number, let me tell you that this number exceeds human consumption of electrical energy for 1,000 years. Rather, the energy that is produced from converting 1 gram of hydrogen into helium equal the energy produced from 20,000 tons of coal. This makes nuclear fusion one of the most powerful energy producing reactions in the universe because it uses very small amount of the substance to get massive amount of energy. This raises a second question: as long as the sun loses mass over time, why is the sun's fuel not finished yet? If we set fire to a group of wood in a camp, for example, over time the fuel for the fire, which in this case is wood, started to run out, and the fire was not extinguished because the wood was scarce. Even if it was a complete forest, it must also be extinguished after running out of wood. This is because the consumption process here is a chemical process in which oxygen is an essential element, as we said at the beginning of the video, and it is not nuclear fusion. And if the sun was working in this way, its age would be very short, just thousands of years. But in fact, scientists estimate that it's more than 4.5 billion years old. This is because the sun or any star in the space has a nuclear fusion process inside it to produce huge amount of energy through small amount of matter that makes up the star. And the simple loss in this mass is what produces this huge energy. And even though we see the sun glows orange and emits heat, however, it is not a huge mass of fire or lava. All we see is nothing but a fusion of atoms. And this is how we answer the question of how the sun burns when there is no oxygen in the space. And if you are the first time to enter the channel, this channel is where we answer the questions that comes to your mind while you are laying on bed in midnight and you don't want to fall asleep. If you like the video, don't forget to like and share. And the people who saw us for the first time, subscribe to the channel and activate the bell to receive our videos once posted. And see you next episode. Goodbye.